Hello my dear friends, welcome to Instant Doubt Electronic. This is Uncle Misha, and today we have another Dollarsore Miracle. Yes, this was purchased cheaply from Dollarsore, and we have Sylvania Smart Plus, not just Smart Plus, soft white bulb with Bluetooth. These are A19. I think A19 is E26 or 29, I forgot, but I think this should be compatible with regular out socket in North America. It's just different nomenclature for the same bulb socket. So these are 800 lumen, which actually pretty decent amount of lumens light bulb, so this should be good. They are 9.5 watts, which is good as well, but I think it's not as good as IKEA Solhetta. Okay, so it's made in China, obviously. Okay, what else we can figure out from this? There is FCC ID, so this is not some, what the heck is this? One hand low stuff, so this is more or less decent stuff. In Sylvania is actually not, again, not some kind of cheapo brand. I don't see warranty, but it doesn't really matter because a warranty may not be applicable because it is purchased in Dollarsore. So let's take a look what the heck we got here. Okay, and it's nicely packaged. Very utilitarian package, I must say, but here we are. Just two light bulbs and little texty here. And here we works with Google, how the heck, this is not, it's just with Bluetooth. How the heck it works with Hey Google? Yeah, it's very interesting, have to figure this out. Make sure your Alexa smart speaker is turned on and close proximity to the device. Power Sylvania smart device and make sure device is in pairing mode. Say Alexa discover device, or go to Alexa app and tap devices. Oh. I don't think my smart speaker, for example, Alexa, I'm not sure. I'm not sure if my smart speaker has Bluetooth. What? Google Home Mini, it doesn't have Bluetooth. Okay, there's something to check. There's something interesting going on here. Clearly we have two very light bulbs. Something dangling in there, and I already believe this is not. Yeah, well, Intertech with Bluetooth, very interesting, and looks like glue here is not so, actually it's pretty good glued. Okay, nicely glued. So let's take a look what the heck are these and how they are, how they work. Interesting that doesn't have, it looks like they are really targeted, this Google and Alexa. There is no app here. Yeah, so I'm not sure what's gonna happen if you pair it, for example, with your phone. So this kind of applies that your Google smart speaker or Alexa smart speaker has to be engaged here. Very interesting. Maybe something useful. Maybe something, because I do have Alexa, as you remember. I can just bring it down here and we do some experiments. But before, we gonna dim this up and check how they are dimmable, how they work, maybe check their power consumption and things like that. Let's do some electrical tests. For these, probably have to zoom out to have a little bit more space. Let's move this crap. Okay, so we have our dimmer box, we have our kilowatt meter and little thingy right here. Let's connect our dimmer box. I have handy contraption right here. And before we power this little guy, so this is dimmable, this is not. I was wrong, so top is not dimmable, bottom is dimmable. Let's first of all figure out what's the electrical parameters here. I'm gonna just plonk it. I was blinking. Okay, let's see power factor. It's not power factor. So power factor is relatively good, 96, not 99 like some other light bulbs, but it's good. 60 Hertz power factor. Okay, let's see the 9.2 watts. That's okay because this is 800 lumen light bulb. Could be better, but that's not bad. It's on par with some of the more or less modern light bulbs. And this is our power factor. Okay, that's good enough. Let's just pull this all out. Yeah, this is really tough here. So now let's try to poke around and dim. Oh, it's already dimmed. So this is how it is dimmable. I do suspect this dimmer is shit. Probably have to MacGyver something which like just this regular rotatable dimmer, because this looks like it's just, especially this fifth stage, seems like it's not working as it is as it is intended to work. But at least it dims, and it looks like this light bulb is a relatively good dimmer on. And now let me see if it blinks or not. For the blinking at this most dim state, I'm gonna use my Galaxy phone, which has high-speed camera. I'm gonna see if this blinks. Okay, so as you saw already, I recorded also full brightness. So definitely this guy has a flicker. Looks like it's 60 Hertz flicker. Yeah, unfortunately. So what next? So next probably gonna be, ideally, if I would have color spectrometer, I would measure the CRI of this guy. Oh, that's what's going on here. Yeah. You know why it just shut on and start doing this weird thing? Because they have this peer sensor. This peer sensor, obviously, after a while, it acts as if someone, like, I don't know how to shut this down. You have to connect to this device and like set it up and things like, yeah, here we are. It just goes on and all. Alright, so just like, let's just shut it down. So next, probably I gonna take it apart because I'm curious what's inside. I am curious what's inside. Yeah, forgot about one thing. So before I actually take this guy apart, I would like to try to connect it, for example, with Alexa. So this is my Alexa. By the way, if you want to see what's inside this guy, check this video.
Something went wrong.
Seriously? Alexa? Are you connected to internet?
Yes. Looks like this device is connected to the internet at the moment. If you are having connection issues, I can take a look to understand what's going on. It could take about 2 minutes.
Alexa,
is that
stop.
Okay?
Stop. No. Smart ass. Alright. I have this.
Yes. Looks like this device is connected to the
Alexa,
internet at the moment.
stop.
Goodbye.
Smart ass. Okay, so we're gonna power this up like this, and it says in the manual, in order to put this thing into pairing mode, have to put it in pairing mode. Have to 5 times power it on and off. 1, 2, 3, 4, 5. Alexa, discover devices.
Starting discovery. This will take a few moments. Turn on your new devices now, and if needed, put them in pairing mode.
Okay, something happening, guys. No idea how that's gonna fly. I don't even know if this guy has Bluetooth, to be honest. Maybe I'm wrong.
First light. Now that you have completed the setup, I have a few basics for you to try. You
Yeah,
can say
found
stop
some
at
kind
any
of
time by
first
saying,
light.
stop. Would you like to get started?
Yes.
Great. Let's start with the basics by turning on your first light. Say, turn on first light.
Alexa, turn on first light.
Okay. Next, to set the mood, let's dim the lights. Say, turn down first light.
Alexa, turn down first light.
Okay. Now let's get your
It
lights
works.
to its brightest. Try saying, increase first light to 100%.
Alexa, stop.
No problem. You can check out the mobile app for some things to try. Or, if you
Alexa?
want to resume the...
Stop. Jeez. I got it. Okay, Alexa, turn off first light.
Okay.
Alexa, turn on first light.
Okay.
Alexa, set brightness of first light to 100%.
Okay.
Alexa, set brightness of first light to 10%.
Okay.
Well, it works. Actually, that's useful. That's actually useful. I'm not sure though how big range of this device, because what's gonna happen, like Alexa, for example, on the second floor, this thing in the basement, like how the heck it's gonna properly work? It's like 3 stories and some concrete in between, right? So yeah, not sure. But this guy seems to be doing well, and clearly now I know that this guy has Bluetooth, and this obviously only Bluetooth. Interesting. So what else we can do? Probably it's enough. So this so in the room where the Alexa is, this is definitely useful. So you'd be able to, for example, put it in your desk lamp and just say turn on and off and things like that. So it's going to be easy peasy. Alexa, set the light of first light to 5%.
Okay.
Okay, so looks like 5% is pretty much. Can we do this? What? Oh no, it does something. Okay. Pink. Okay. Right, it works. Okay, so now let's go to the disassembly. I think we're done here. Alright, so it's time to take it apart. So let's take some tough things which will help me to poke around this light bulb. We're gonna jam something like in here, and I'm just gonna not easy. Not. Alright, I was able to insert this thing, and now I'm just gonna wiggle it on the perimeter. Then I'll I hope I'm not gonna scrape LEDs right there by doing that. Oops, something is cracking. Let's take bigger one. I'm not gonna use any kind of sharp object because, as you see, I would already be cutting myself a few times. Ta-da. Oh, look at that solution. It's kind of funky. So we have LEDs which are nicely indicated. So we have, for some reason they are indicated as W's. Looks like we have 18 LEDs. W1 all the way to W18. Okay. This is our... Okay, it looks like it's soldered. I thought you're just gonna just unplug it like a SIM card. It'd be like hilarious. So let's try to scrape a little bit of this goop. This is essentially glue. And scrape this goop a bit. Oops, I hope I didn't damage the LED. I have to do it carefully. I still want this thing to work, right? I don't want to... I'm gonna reglue all this jar, so hope I'll... Okay, it's probably some kind of sharper thingy. I'm gonna essentially do this. I'll try to lift this thing. Stay with me. Alright, so I was successful in yanking this board from here without destroying this side. So how did I do that? You see this guy? So I hooked it up like this and boom! Anyways, this is how it worked. Take a look at that. We have a little bit more goodies going on, but unfortunately, unless I use some kind of pliers, I won't be able to pull this board out because it's highly light. First of all, it is nicely... Yeah. I need something. Let's get these guys. Try to... It's probably soldered, or glued. That's probably soldered somewhere. Oh, I wish I could. Essentially, if I'm gonna yank it, I won't be able to assemble it back together, obviously. But it's a little bit more advanced than I thought. Looks like it's a little bit more advanced because looks like this guy has switch mode power supply. Yeah, this is interesting. I thought this is gonna be much simpler than that. Look, there is a transformer, right? There is a controller chip right here. Well, it's really hard to say what it is exactly, but yeah. So a little bit more than I expected. It's oh well, to actually power up this board, which is well, it says no, this is not this board. It's made in 2020, January. Okay. Yeah, how do I approach this? I don't wanna destroy it, really. Honestly, I don't wanna really destroy it. I don't wanna destroy it, but maybe I have to. Just gonna yank it, I guess. I'm gonna just, I guess, break the wire off. Yeah, I don't have any other. Like, it'd be nice. Oh, maybe this is gonna help me. So we're able to reach it out. No, I'm just gonna break it off. And then resolder somehow. Yeah, here we are. So here we are. So this was obviously outer shell here, which is easy to, I don't know how you're gonna connect that back stuff. No, it's probably Gonski. Yeah. Anyways, this is fusible resistor. This is our mauve, is it? Or is it just a safety capacitor? Looks like safety capacitor. There is CLC filter, 100 volt. Why 100 volt? What? Oh, okay. So this is on LED output, 100 volt capacitor. So essentially, this panel, this LED thing doesn't run on high voltage. It's run on like less than that. Probably runs on, I don't know, 70 volt or something. Then we have it's one bridge rectifier right here. Okay. It's just interesting. It says here 3.3 volt. I'm just wondering. It's positive. I don't believe 3.3 volt goes in here. Like, this would be insane. But who knows? Like, I can test that. I can really test it. That's easy. If that's gonna be 3.3 volt, this is actually quite valuable panel. If I even didn't put it all together, this is interesting because this is there is no current limiting of any kind. So yeah, this is crazy because this little Bluetooth controller is definitely gonna run at 3.3 volt. What kind of driver is that? We have a Xener here. We have what kind of capacitor? 25 volt, 150 microfarad. What is this? This is probably primary capacitor, 400 volt, 1 microfarad. Okay, so this is primary capacitor. This is the controller. This is a few diodes, probably flyback configuration. Then we have output stuff. Unless they're referring 3.3 volt specifically on this particular pin, potentially, potentially is here. Because Xener and here is capacitor and this goes to here, so I assume that there is also this old jazz has to be dimmable, so it has to be control. Wait, we have two chips, one and two. So yeah, so one of them have to provide dimming capabilities to here. So 100 volt, I don't think it's 3.3 volt, highly unlikely. But this is really confusing, this 3.3 volt here. Nice. Okay, let's see what the heck we got here. 8250 FG EWM 8250 FGT1AA, and there is a FCC ID and IC ID. The Bluetooth module. It's really hard to see. Sorry guys. What specifically kind of Bluetooth is this? I need to Google that. Also I need to understand what are these chippies here. Also, I'd like to try put 3.3 volt right here. Let me do that. Voltage. I don't think so. I don't think so. It'll be too crazy. 3.3. Current is, I don't know, 100 milliamp. Okay, 100 milliamp, 3.3 volt. I don't think so. I think that's going towards the other pin. Yeah, nothing really. Yeah, they are connected in series, they are not parallel, so yeah, it'll be higher voltage than 3.3 volt, for sure. For sure, yeah, they are connected in series. Alright, so yeah, it's probably much higher voltage. And but nevertheless, you just need to figure out what is this guy 8250 FG, and also to see what are those chippies here. Okay, I will be back. Okay guys, I've done some figuring out, and okay, so this gentleman right here is, no one knows, but this is EWM 8250 FGT1AA. It's one, not A. So this is Bluetooth Low Energy SoC, has 500 kilobyte flash. I found the data sheet for that, so I'm gonna include it in a specific article. 48 kilobyte of RAM or flash. Not sure if it's a flash only or something, but it has data memory 48 kilobyte. It has bunch of GPIO, PWT, it has a word, and like, which is amazing actually, 14-bit ADCs, which is crazy. Why would it need that? But probably for some kind of data acquisition. But that's Yeah, but it also support Tmall Genie Mesh, whatever it is. So essentially this guy supports meshing. I'm not sure how in this scenario it's gonna mesh. I'm not sure if mesh works with the Alexa, but 125 500 kilobit per second mesh. Really decent actually, I must say. Then BP2306, this gentleman here, which is pulse width modulated analog, dimmable, high precision, non-isolated LED driver. Here we are, this guy that I suspected, it's kind of in this proximity, so, and obviously it runs at higher voltage, runs those LEDs in higher voltage. Oh, by the way, check this out. Let me show you something. So these LEDs are actually, oops, let's clearly indicate negative here, right? Here, this thing, I thought it's a dash. No, it's negative. Look at this. You see that? Ta-da! Hey, here we are. So, I'm just running my multimeter in a diode mode, and it's showing, it's actually illuminating those LEDs, but doesn't show the voltage. Probably is too high. Again, it's really hard to say why LED tester, diode tester doesn't show anything. Probably voltage drop is too big. Yeah. All right. So we have 18 and 3 inside. So it's yeah. I'm just curious on this panel. This is from IKEA Solhetta, by the way. This is how it looks like. I'm gonna show you some other day. Yay! The same story. Looks like some of the LEDs are dimmer than another. That's weird. Huh. What? Looks like quality here is shit. It's not even working. Unless it's just polarity is different. Yeah. But that's going to be another story. So we have 54 LEDs right in here. 18 and 3 are in parallel. So these are parallel LEDs, and all of them are in series. So this is different by color, by the way. So by the way, you see this, like it's 12 LEDs here of more like a reddish color, and 6 LEDs here is a bit brighter. So looks like they done some management in order to achieve 27. I think it says 27. Where is the box? Huh. I don't see the color temperature anywhere here. No color temperature. Oh yeah, here. So here's the color temperature. Shit, it's very hard to focus. 2700, as you barely see. So yes, so they manage the color temperature by using the different LEDs. So let's continue. This little chippy right here is a BP2525X, the ultra low standby non-isolated constant voltage driver, and this guy specifically is for a regulator for this guy, for a Bluetooth module. Yeah, so this is for LEDs and this is for Bluetooth. I never seen this setup before, but like then you have two different regulators. By the way, this is not transformer. This is a choke. So because two of them need output inductor. So this guy need output inductor and this guy need output inductor, and this transformer is an output inductor for this thing, and this little choke and this capacitor is output transformer, output inductor for this 3.3 volt Bluetooth SoC. So here we are. This is pretty neat. I actually kind of positively surprised. I thought it's gonna be like super chintzy something, but it's not super chintzy. And I think for $2 I paid for this, it's actually not too bad. Unfortunately, I mean, I can, like, I mean, I can't just plug it like this and plop some wires here and just run it, like, but it's like, this thing is not isolated. It's like crazy dangerous touching this thing, so obviously I have to put it in some sort of container or somehow try to MacGyver it back into here, because I didn't do any super destructive anything, well, except those wires somehow have to come back, somehow come back in there. Have to figure out something. Like the central one would be easier, and central one is fused right here, because I can just drill a little hole through here and just thin and solder it. But how I gonna solve this problem? Probably the same way. Drill a little teeny tiny hole right here and just you know, wire some kind of wire and then solder it and just push it in here, so something to this extent. I maybe not gonna do anything. Anyways, it's nothing to like really write home about, but still interesting LED bulb, and I think it's a really decent solution here. I think it's like kind of old school, because modern light bulb are a little bit more advanced, but I never actually tore down any smart bulbs yet, just because the others I have, they cost way more than that. So I for price of $2 I decided to actually give it a shot, and I'm actually positively surprised. Oh, another very important factor here, sorry, I forgot to mention, all capacitors are 130 degree rated. All three of them, all those three guys, 130 C rated capacitors. So this gives some kind of hope that they're gonna last a little bit longer. Obviously they are no name brand, all three different brands, by the way, whatever they had in a drawer at that day, but or the Shenzhen market, like some other people say, but still, nevertheless, 130C rated. I don't know if you can trust this rating, but 130C rated. All three capacitors, all three electrolytic capacitors, which is pretty good. So I'm gonna take some shots of this PCB and gonna share it on my website if you are interested. Maybe, you know, if you want to poke around and you know, or a repair or something, diagnose issues with your light bulb to see what's going on there. So guys, thank you for watching. Hope you like this sort of video. If you like, please support my channel, please like, please subscribe, please comment, and see ya next time.